We notice chemical reactions in our everyday life, such as the leaves changing color in the fall or the rusting of metals. These are caused by a chemical reaction, which is the process in which atoms are rearranged to produce a new substance. During a chemical reaction, the bonds that hold atoms together may be formed or broken.
Hello everyone, and welcome back to H&H Knowledge Hub. Today's video is going to be about chemical reactions.
Evidence that shows a chemical reaction had taken place is when there is a color change, a change in odor, precipitate formation or the formation of solids, appearance of gas bubbles are all evidence of a chemical reaction. How are chemical reactions modeled? You can describe the substances before and after a reaction by their properties. You could use symbols to identify the substances. Each element has its own chemical symbol. A chemical formula uses chemical symbols and numbers to represent a given substance. The chemical symbols in a chemical formula tell you what elements make up the substance. The numbers written below and to the right of the chemical symbols are called subscripts. Subscripts tell you how many of each type of atom are in the molecule. For example, the chemical formula for water is H2O. The subscript 2 tells you that there are 2 atoms of hydrogen in each water molecule. There is no subscript on O, so each molecule of water contains only 1 oxygen atom. Chemical equations also help us model chemical reactions. A chemical equation is an expression that uses symbols to show the relationship between the starting substances and the substances that are produced by a chemical reaction. The starting substances, known as the reactants, are the substances that will be involved in a chemical reaction. An arrow, known as the yield sign, points from the reactants to the products. Products are substances formed in a reaction. How do chemical equations show the law of conservation of mass? The law of conservation of mass states that matter is neither created nor destroyed in ordinary physical and chemical changes. This law means that a chemical equation must show the same number of atoms and the same type of elements on each side of the equation. What happens to energy during chemical reactions? Changes in energy are part of all chemical reactions. Chemical reactions can either release energy or absorb energy. Energy is needed to break chemical bonds in the reactions. As new bonds form in the products, the reactants release energy. Reactions are described by the overall change in energy between the products and reactants. Energy could be absorbed using an endothermic reaction. An endothermic reaction is a chemical reaction that requires an input of energy. The energy taken in during an endothermic reaction is absorbed by the surroundings, usually as heat. This is why endothermic reaction mixtures often feel cold. Photosynthesis is an example of an endothermic process that absorbs light energy. In photosynthesis, plants use energy from the sun to change carbon dioxide and water to oxygen and sugar glucose. Energy could also be released using an exothermic reaction. Exothermic reactions is a chemical reaction in which energy is released to its surroundings. Exothermic reactions can give off energy in different forms. For example, you feel the warmth and see the glow when a candle burns. Burning is an exothermic reaction. The products of the reactions are lower in energy than its reactants. Some of the energy in the bonds of the reactants change to energy as heat and light. Exothermic reaction mixtures often feel warm when heat is released to its surroundings. During all chemical reactions, energy is always conserved. The law of conservation of energy states that energy cannot be created or destroyed. However, energy could change form. The total amount of energy does not change in an endothermic or an exothermic reaction. For example, light energy from the sun changes into energy stored in chemical bonds during a photosynthesis. Thanks for watching! If you like this video, don't forget to like, share, and subscribe if you haven't already. For more science videos, check out our channel